Welcome to Creata classes. In this lecture, we will study the section formula. For explaining the section formula, let's check our coordinate system, and also we will take the 2 points, that is point A and point B. On joining point A and point B, we got a line segment AB. Let's assume a point P on this line segment AB. This point P is dividing this line segment AB into certain ratio. Let's assume this ratio as M1 is to M2. The ratio of AP is to PB is M1 is to M2. So basically, this point P is dividing the line segment AB into some ratio that is M1 is to M2. So in this section formula, we will find the coordinate of the point P. This is the introduction to the section formula. That is, in this lecture, we will establish a formula to find the coordinates of a point which divide the line segment joining the two given point in a given ratio. Here this given ratio is M1 is to M2. Okay, this is the introduction to section formula. That is what we are going to do in this lecture. So let's move further and let's derive the formula. Let's assume the coordinate of point A as x1, y1 and the coordinate of point B as x2, y2. We got the coordinate of A and B. And let's assume the coordinate of point P as x, y. In the section formula, we have to find the coordinate x, y, that is, we have to find the coordinates of the point P. Moving further, the coordinate of point A is x1, y1, means the x coordinate of point A is x1 and y coordinate is y1. Similarly, the x coordinate of point B is x2 and the y coordinate of point B is y2. The coordinate of P is x, y. So we can say the x coordinate of point P is x and the y coordinate of P is y. These lines are perpendicular to x-axis and y-axis. Further, on extending these lines, are you able to observe these two triangles? We are able to observe two triangles. Let's give these 2 points as point Q and point C. We got two triangles, that is triangle APQ and triangle PBC. These lines are perpendicular to x-axis and these lines are perpendicular to y-axis. Means these three lines will be parallel to each other. So can we say these angles will be equal to each other? And also these angles will be equal to each other. And angle Q and angle C both are 90-degree angle, that is, these angles are also equal to each other. So can we say both of these triangles are similar triangle? Okay, all the three respective angles are equal, so we can say both of these triangles are similar to each other. So we can say the ratio of their sides will be equal, that is, PA upon BP is equal to AQ upon PC is equal to PQ upon BC. We got the ratio of the sides as equal to each other. Further, let's see the sides of this triangle. If we observe the triangle APQ, can we find the length of the side AQ? Here this complete length is x and this length is x1. So can we say AQ is equal to x minus x1? Similarly, we can also find the side PQ, which will be equal to y minus y1. If we move to the triangle PBC, in this triangle, we can also calculate the side PC and BC. PC will be equal to x2 minus x and BC will be equal to y2 minus y. Okay, the simple mathematics we have applied. We got the sides of this triangle. So let's come back to our equation. Let's put the value. Here PA upon BP will be equal to M1 upon M2. Why? Because the point P is dividing the line segment AB into the ratio of M1 is to M2. Don't be confused here, M1 and M2 are not the hypotenuse for this triangle. M1 and M2 are just the ratio of this triangle. So we got AP upon PB, that is the ratio of these two sides as M1 is to M2. Okay, got it? Further, if we take these two parts and these two parts separately, we got two separate equations. Here in the first equation the variable is x, and in the second equation the variable is y. Let's solve both of these equations separately, and we got the value of x as m1 x2 plus m2 x1 upon m1 plus m2. Similarly, we got y as m1 y2 plus m2 y1 upon m1 plus m2. We got the value of x and y, that is, we got the coordinates of the point P. The coordinate of the point P is x comma y, that is, this is the coordinate of the point P. This is the section formula. That is the coordinate of the point P, that is dividing the line segment AB into the ratio of m1 is to m2, where the coordinate of point A is x1 y1 and the coordinate of B is x2 y2. Okay, you have to remember this formula. Just look at this formula. m1 plus m2, that is the addition of the ratios, is same in the denominator. Okay, that is m1 plus m2. Further, in the numerator, m1 and m2, it is also common in both the terms. Just you have to remember x2, x1, y2, y1. This is the section formula. Further, let's take a case. The case is that if point P is the midpoint of the line segment AB. Midpoint means m1 is to m2 will be equal to 1 is to 1. Let's put the value. On putting the value, we got the coordinate of point P as x1 plus x2 by 2, comma y1 plus y2 by 2. This is a case of a section formula when the point P is at the midpoint of the line segment AB. Okay, so let's take some questions to show the implementation of the formula. The question is, find the coordinates of the point which divides the line segment joining the points 4, -3 and 8, 5 in the ratio 3 is to 1 internally. This question is talking about 2 points. The coordinate of first point is 4, -3 and the coordinate of second point is 8, 5. This question is also talking about another point which is dividing the line segment joining these 2 points. And it is dividing into the ratio of 3 is to 1. And we have to find the coordinate of this point. So here the section formula will be applicable. Here x1 y1 will be equal to 4, -3 and x2 y2 will be equal to 8, 5. m1 will be equal to 3 and m2 will be equal to 1. We got all the variables. Let's put it into our formula, that is the section formula. On putting the values and solving, we got the coordinate of x as 7 unit and the coordinate of y as 3 unit. That is the coordinate of the point is 7, 3. This is the answer of the question. Okay, got it? Okay, let's take our next question. The question is, find the ratio in which the line segment A 1, -5 and B -4, 5 is divided by the x-axis. Also find the coordinates of the point of the division. Pause the video and try to solve the question on your own. Here this question is talking about 2 points, that is point A whose coordinates are 1, -5 and the second point, that is point B whose coordinates are -4, 5. These 2 points are joined by a line segment and this line segment is divided by the x-axis. And we know on x-axis the y coordinate is 0. If we assume the point P means the point which is dividing this line segment into some ratio, and this point P is coming on the x-axis, means the coordinate of this point will be x, 0. Here we have assumed the x coordinate of point P as x, and we know at x-axis the y coordinate will be 0. Okay, so we got the coordinate of point P as x, 0. Further, let's assume this point P is dividing this line segment into the ratio of k is to 1. Here m1 is to m2 we have assumed as k is to 1. Okay, got it. For simplicity, we have assumed m1 is to m2 as k is to 1. Further, we have to calculate the ratio in which the point P is dividing this line segment into. We also have to calculate the coordinate of the point of the diversion. That is, we have to calculate the coordinate of the point P. Okay, so let's use the section formula. Here m1 is k, m2 is 1, and x is x and y is 0. Firstly, we will take down the y coordinate because we know y is equal to 0. We know y is equal to m1 y2 plus m2 y1 upon m1 plus m2. We know y is equal to 0 and m1 is equal to k and m2 is equal to 1. Okay, let's put all this value and the coordinate. On solving, we got the value of k as 1. That is, the ratio k is to 1 will be equal to 1 is to 1. That is, the point P is dividing this line segment AB into the ratio of 1 is to 1. Okay, got it? We got one part of the answer. Let's move to the second part where we have to calculate the coordinate of the point P. And we know the coordinate of point P is x, 0, means we have to find the value of x. Okay, let's apply the section formula. We got x is equal to m1x2 plus m2x1 upon m1 plus m2. We know all the values. Let's put it. On solving, we got x as minus 3 by 2. Means the coordinate of point P, that is x, 0, will be equal to minus 3 by 2, 0. This is the answer to this question. Okay, got it? Let's move to next question. The question is, if 1, 2, 4, y, x, 6 and 3, 5 are the vertices of a parallelogram taken in order, find x and y. Pause the video and try to solve the question on your own. Okay, let's come back. This question is talking about a parallelogram whose 4 vertices are given. Okay, these are the 4 vertices of a parallelogram. Let's give name to these 4 vertices as A, B, C and D. Here in this question, we have to find the value of x and y. That is, we have to find the coordinate B and C. Y is missing in the coordinate B and x is missing in the coordinate C. So how we will approach this question? We will use the property of the parallelogram, that is, the diagonal of a parallelogram bisect each other. This is the property of the parallelogram, that is, the diagonals of the parallelogram bisect each other. So firstly, let's draw the diagonal, that is AC and BD. These are the two diagonals and these two diagonals are meeting at the point O. As per the property, AO will be equal to OC and OD will be equal to OB. That is, O is the midpoint of the diagonal AC and O is also the midpoint of the diagonal BD. Based on this property, we will try to solve this question. So firstly, let's take the diagonal AC. Here let's assume x1, y1 as the coordinate A and x2, y2 as the coordinate C. Here the point O is dividing this line segment into the ratio of 1 is to 1. Okay, O is the midpoint of AC. So O is dividing this line segment into the ratio of 1 is to 1. Means M1 is to M2 will be equal to 1 is to 1. That is, M1 is 1 and M2 is also equal to 1. So let's apply the section formula. On applying the section formula, we got our x coordinate as x plus 1 upon 2 and we got our y coordinate as 4. Simply we have put the value and we have solved it. Okay, got it. Now let's move further to the next diagonal, that is the diagonal BD. Same fundamental we will apply. Here the point O is the midpoint of BD, that is M1 is to M2 will be equal to 1 is to 1. That is, M1 is equal to 1 and M2 is also equal to 1. Let's apply the section formula. We got the x coordinate of point O as 7 by 2 and we got the y coordinate of point O as y plus 5 by 2. Okay, we got the two coordinates of point O. Let's equate both of these coordinates. So firstly, let's solve for x. We got 1 plus x upon 2 is equal to 7 by 2. On solving, we got x is equal to 6. Similarly, let's equate the y coordinate. On solving, we got y is equal to 3. Okay, we got value of x as 6 and we got y as 3. Okay, that is the answer of the question. So how we have approached this question? We have applied the section formula and we have applied the property of the parallelogram, that is the diagonals of the parallelogram bisect each other. So based on these properties, we have solved the question. Got it? Let's move to the next question. The question is, find the coordinates of a point A where AB is the diameter of a circle whose center is 2, -3 and B is 1, 4. Try to solve this question. Pause the video and solve the question. Here this question is talking about a circle whose diameter is given as AB. The coordinate of B is given as 1, 4 and we have to calculate the coordinate of point A. Let's assume the coordinate of point A as x, y. In the question, the center of the circle is also given as 2, -3. Let's assume the center point as C. Here AB is the diameter and C is the center. Means the C is dividing the diameter AB into two equal parts. That is into the equal ratio. So we got AC is to CB is equal to 1:1. Here the point C is dividing this line segment AB, that is diameter of the circle, into two equal parts. That is 1:1. So we will apply our section formula. Let's apply the section formula. Firstly, we will take the x coordinate. So on putting the value, we got 2 is equal to x plus 1/2. Here x is a variable. Let's find the value of x. On solving, we got x as 3 unit. Similarly, let's use the section formula in the y coordinate. We got -3 is equal to y plus 4/2. On solving, we got the value of y as -10. We got x and y are the x and y coordinate of point A. So we got our coordinate of point A as 3, -10. This is the answer of the question. Okay, so how we have solved this question? We have applied the section formula and we have also applied the property of the circle, the basic property, that is center is dividing the diameter into the equal ratio, that is 1:1. So based on these simple properties, we have solved this question. Okay students, that's it for the section formula. Thank you very much for being with Creata classes. Bye for now.